Hi there. This is the first in a series of videos that are intended to present and discuss problems that will be helpful to understand before taking Algebra 2. As problems are presented in the videos, you may want to read them and work on them first before watching the discussion in the video. The first problem asks us about irrational numbers. We want to identify from the group below the irrational numbers. As it turns out, the two numbers that are irrational in this list are the square root of 27 and the square root of 10. And when you're working algebraically, square roots are often values that will be irrational. But not always. If the radicand, if the expression under the square root is a perfect square, that number will simplify to be a rational number. So the square root of 25 just equals positive 5, and negative square root of 16 equals negative 4. When you're working with a decimal expansion, if the decimals terminate, then that number is going to be rational. So this is equal to negative 73 over 100, for example. And if there's a fixed repeating sequence, like in this case, the bar above the 27 means that the 27 is repeated, 3.272727, and so on forever. In that case, we also get a rational number. This would be equal to 3 plus 27 over 99. We can take that two-digit repeating sequence and place it over two nines, like that. And this, of course, would simplify to be 36 over 11. If the radicand is not a perfect square, the decimal expansion will never terminate or repeat in a fixed sequence. But we can sometimes simplify. 27 has a perfect square factor. 27 is 9 times 3. And we can actually take the square root of that 9 because 9 is a perfect square. So the square root of 27 simplifies to 3 square roots of 3. But because the radicand 3 is not a perfect square, that number overall is still irrational. So the square root of 25, negative square root of 16, and these decimal values are all rational numbers, but the square root of 27 and the square root of 10 are irrational.